Fearless Leader here, coming at you with another video. I know you've been just so sad that there haven't been any new ones for a couple days, so here is your fix. I'm looking here at the textbook and notice that this is a PDF, and I'll put a link to this page in the upload to the video. So I wanted to talk about this future value of an annuity because I think it's hard to get your head around this formula if someone doesn't walk you through it. So recall that an annuity is some sequence of equal periodic payments, meaning they happen regularly. So remember when we did compound interest, we had semi-annual, annual, quarterly, that sort of thing. Compounding, that's a periodic event. Now, if you add money at the end of each time interval, then you get yourself an ordinary annuity, and that's the only kind we care about in this class. The future value is related to the compound interest formula, but it ends up being a sum of results of the compound interest formula. And so here's a nice example. Suppose you deposit $100 every 6 months into an account that pays 6% interest, compounded semi-annually. Remember, that's twice a year. If you make 6 deposits, one at the end of each interest payment period over 3 years, how much money will be in the account? So let's look at A equals P 1 plus I to the N. A is future value. No, that's not true. A is present value, and this is the compound interest formula, not quite an annuity yet. I know, wouldn't it be nice if A were for annuity? Sorry. Initial investment. I is the periodic interest rate. Let's see, N is number, not hashtag, number of periods. Number of periods. So our book suggests that we think about this as a timeline, and that's not such a bad idea. So what we have is deposit number, year, so one, or let me call it initial so the initial deposit is $100, and this is the initial year. So second deposit, I guess I can call this the first deposit. This is year 1. Now I know what you're thinking. Why is that year 1? Because I guess this is year 0 when we started. Well, actually, I should be careful because let me just show you the table they have. I think it'll make more sense if we look at theirs. Somebody made this table prettier than I could. So after one period, $100 is there. After 2 periods, there's another $100. So after 3 periods, we add another $100. 4. There's the idea. So notice that the future value is all of these added together. And we could certainly do this multiplication, this, add them together, but that's kind of a pain. And imagine if we were doing this for like 20 years. There has to be a better way. And it turns out there is. So I'm going to get a new one here. Command N, don't save. All right. So what we have here is, I'm going to call this S, and this is future value. And I'm just using this because that's what your text uses. So we have our initial investment, and then 1.03, because remember 0.06 divided by 2, this is per year, and then 2 compounds per year, 0.03. So that's the, and then we add 1 to that, plus now the next one is from the compound interest formula squared, and 1.03 to the fourth, 100, sorry, I'm going to go downhill here. It's kind of hideous, but whatever. And so you're like, well, that's very nice, Dr. Fisher. We already had that. But here is a really brilliant observation that someone way smarter than me made, is what if we were to multiply through, well, let me back up a second. Do you see that all of these terms, except this one, terms are separated by addition, have a 1.03 to some power? Well, let's multiply both sides by 1.03. We can do that. 100, 1.03 to the third, 100, 1.03 to the fourth, plus 100, 1.03 to the fifth, plus 100, 1.03 to the sixth. Now I want to emphasize at this point that this is not how you solve these problems. We are doing this process so that you can understand where this formula comes from. This is how you derive the formula for an annuity. And I want you to just see this so you know where it's coming. You just use the formula when you're doing your homework problems, but if you know where it comes from, I'm hoping it will be less mysterious. So now let's take 1.03s minus 1s, this term minus that term. And what happens is those cancel, those cancel, those cancel, those cancel, those cancel, and then we're left with 100, 1.03 to the 6 minus 100. Then of course these are s's, not 5's. Now gaze at this for a moment, channel your inner algebra beast. Notice that both of these terms, separated by subtraction, which is adding the opposite, have a factor of s. So I can write s here and s here, or I can write s here and then use parens to indicate that both of these terms have a factor of s. Both of these terms have a factor of 100. And remember that s was the number we wanted, and we now have s times 0.03. That's what happens when you combine these, 1.03 minus 1. 100, and I know that we could evaluate this at this point, but I'm not going to, because let me divide through by 0.03. So behold, then notice that for any amount, any I to the n minus 1 over I. There's that formula. Notice that in this particular example, A was, or excuse me, that's P, not A. Notice that, and let me just confirm that I'm writing this down. R, I guess we're calling it instead of P. So, R. Do you know why pirates are so mean? They just are! Sorry, just being weird. So that's what is going on with the compound, with the annuity formula. So that's why there's a 1 plus I to the n minus 1. That's why you have to multiply the whole shebang by r and then divide by I. So I hope this video was helpful to you. Look forward for more in the near future.